Okay. Yeah, so we will start with topic vectors. Like vector is any physical quantity which have magnitude and direction. These two things. Like let us say you have started from this point A and reached a point B. Okay. So your journey can be represented by this situation where the length is showing you the actual distance or displacement and the arrow is showing the direction. So it means from A to B you have traveled. A was the starting point and B is the ending point. Okay, so I can call it AB vector. We can represent it with AB vector. Okay, an AB vector, but in general, to understand it, you can read it AB vector, but we can say it displacement. Any vector okay, AB vector. You can read it AB vector or what? Displacement AB. Displacement AB. Why? Because vectors are quite easy to visualize if we see in terms of displacement. Displacement AB means you displaced A to B. Okay, so this is about vectors. Generally, so every vector has some component. Every vector has some component. Like when I say you have displaced from point A to point B. So we try to visualize our displacement in two way. How much how much you have displaced in x direction and how much in terms of y direction. So if I say, can I say, let us say I move this way and then this way. Let us say this is 2 unit to the right and 1 unit to the up. On x-axis, I moved 2 unit toward positive x-axis and 1 unit toward 1 unit toward positive y-axis. Will I be the green one? The green journey is same as the white journey in terms of displacement. Okay. So therefore only we can say AB vector is nothing but this 2 unit and then 1 unit. This is called column vector notation. Okay, so we are quite okay about this AB vector equals to 2 1. Next, let us see if I just multiply with let us say if I just multiply it with what? No. Okay, so where is this multiplication by a scalar? Yeah, here we will understand. Multiplication by a scalar means what? Multiplication by a scalar mean let us say there is some AB vector, and graphically I am showing you the graph of AB vector. Let us say this is AB vector. Okay, you can see the distance also and the direction also. So now if I say can you represent a double the AB vector? So double the AB vector means nothing but double the AB vector means ki just lengthwise or magnitude wise. Lengthwise you can see the length of AB vector is this much. Lengthwise your length will be doubled. So like this will be your double the AB vector. Okay, and let us name it at a CD vector. So my CD vector is nothing but double the AB vector. So can I represent a CD vector as this one? See, lengthwise what I did lengthwise I try to double it. So this is if length is this 4 units or 4 centimeter. So here the length is 8 centimeter or 8 units. Direction or inclination wise, both are same. AB and CD. I have not changed direction. So CD vector is double the AB vector means lengthwise you are double the AB vector. Okay. What about let us say again one more vector like PQ vector. If I have PQ vector is nothing but minus 1 times minus of let us write minus 1 or just of minus of AB vector. So we have AB vector here and I am saying I am giving you a relation. PQ vector is nothing but minus of AB vector. Definitely you can see this is nothing but minus 1 times AB vector. And here we just saw when I multiply AB vector by any constant, it its length changes. So here I am multiplying AB vector with minus 1. So what is this minus sign does? The minus sign just changes the direction. So if your AB vector is this way from A to B, my PQ vector is nothing but, if you ask me my PQ vector, lengthwise it will be exactly same. as AB 4 centimeter only, but PQ vector. Okay, PQ vector means I have to start from P and end at Q. That's it now. PQ vector. So what we can see, when I multiply with negative sign, the direction gets opposite. Okay, so this was the second concept, and I think if you understood about the what happens when I multiply with any constant and what happens when I multiply with a negative sign. These are the two concepts that I think, yes. Now we can see parallel vectors. Next concept. So here I have to explain you what is parallel vectors. Vectors having same line of action. Vectors having parallel line of action. Line of action. And what is line of action? We will see this. That's it. Let us say this is AB vector. This is some AB vector. Okay, this is AB vector. And can you see this one, PQ vector? Okay, let us mark it as or QP vector. I wanted to mean. So I have two vector. One is AB vector and one is QP vector. Do you so first we will have to understand what is line of action. Line of action for any vector. Line of action means just the line. Like if you ask me line of action for AB vector, I will just see this line. Nothing. No arrow. Just see this line. Okay. Line of action mean the line without arrow. So do you think the line of action of AB vector and line of action for QP vector are parallel? Yes, that's quite visible. Both vectors have parallel line of action. Therefore, what we can write? Therefore, definitely we can write AB vector. AB vector is parallel to PQ vector. Okay, let us again and try to. This is my PQ vector. If I say this one, if I say this as something, something, something. Okay, let us say this is RP, RP vector. Okay. So what do you think about these three vectors are parallel? These all three. Right now, I wanted to discuss with all three vectors. So all three vectors are parallel or not parallel? Because line of action of all three are parallel, definitely. Yes, so all three vectors are parallel. AB vector is parallel to PQ vector is parallel to PR vector. PR or RP vector, sorry. If I have this arrow, I should say RP only. First, you have to say the starting point and then the ending point. Okay, so now, yes. So now about parallel vectors, we have to understand some notes. Notes means, let us say it this way, the first note. What about if I write something like this, ki AB vector is nothing but double the PQ vector, double the CD vector. So let us try to understand the interpretation. AB vector is double the CD vector. So graphically, if you try to draw the graph, let us say this is AB vector. This is nothing but AB vector. Okay, AB vector is double the CD. So first I will draw CD. This is CD. Let us say this is CD vector. Okay. And what about AB vector? You are saying when you say AB vector is double the CD vector, mean lengthwise it is double than CD. Direction wise both are same. So definitely I will write like this. Just I will double the length. So this is AB vector. Can I represent it this way? Can I represent it this way? See, lengthwise I try to double it. So let us say this is 3 centimeters. Let us say this is 3 centimeter and this is 6 centimeter. Okay, lengthwise I am trying to write. Now, so okay. Now what can when we have A vector equals to 2 times CD vector, can we say this AB vector and CD vector are parallel? AB vector and CD vector are parallel? Yes, we can clearly see AB vector and CD vector are parallel. So the note point about what the note point that we will notice, let us say there is some A vector and that is equals to K times B vector. Whenever I have relation something like this, one vector is equal to K times some another vector, where K is any constant. We just saw these two vectors are parallel vector. Therefore, what does it mean? A vector is parallel to B vector. Okay, here see, I am representing just with a single A vector. Mean ki starting and ending point I am not mentioning. You can like this vector. This is some A vector. You can represent it this way also, like A vector. Okay, yeah. First note point was this: ki whenever I have A vector equals to K times B vector, it clearly means that both vectors are parallel. Second output about it, I will give you with example, and let us say it this way. I'm giving you some AB vector. Let us assume that AB vector equals to double the A vector plus 3 times B vector. Okay, let us assume like this. Yeah. And what about some another vector CD vector? That is nothing but 4 times A vector plus 6 times B vector. See, I here we have two vectors, AB vector and CD vector, correct? AB vector and CD vector. Okay. Is there any relation just by looking at the vectors 2A plus 3B and CD is 4A plus 6B? Yes, definitely we have. So what the first note point here, the note point is if you try to find the ratio of coefficient of A vector, here it is coming 2 by 4. That is nothing but 1 by 2, correct? 1 by 2. And what about ratio of this two? Ratio of this two 3 by 6. 3 by 6, that is coming as 1 2. So here the first note point is key the ratio of coefficient of A vector and ratio of coefficient of B vector are same. Okay, first note point. Second note point, if you ask me my CD vector, I can write CD vector is nothing but, can I take 2 common from this? Yes. If I take 2 common, it will be 2A plus 3B. That's it. So yes, that's it. So CD vector is nothing but double the 2A plus 3B is nothing but AB vector. AB vector. So can I say this way? If the ratio between the coefficient of A vector 2 by 4, that is 1 by 2, and B vector, that is 3 by 6, the ratio is 1 by 2. If these two ratios are equal, then we will get some relation like this: CD equals to double the AB, and we know given here we whenever we have a first vector is equal to some k times another vector, we can say what? Yes, we can say these two vectors are parallel. That's it. So the node point, if two vectors are parallel, then the ratio, the second node point. Okay, so let us write node point here again. If two vectors are, if A vector is parallel to B vector, if some A vector is parallel to B vector, then definitely, then you can write A vector equals to some k times B vector. First node point, this was the first node point. And second node point, if two vectors are parallel, if AB vector is parallel to CD vector, and if I give you AB vector equals to KA plus PB, let us KA vector plus PB vector, and CD vector is nothing but K1 A vector plus P2B vector. Suppose these are the coefficient. Therefore, what will be the second node point? The ratio of the coefficient of A vector will be same as the ratio of coefficient of B vector. That means K upon K1 will be equals to P upon P2. So these are the two important point. Based on these two important node point. Okay, these two important node point number 1 and point number 2. All the questions of vector geometry basically we can attempt. Yes. So we have few questions do we have? Okay. So one more concept we have to understand about collinear points. So about collinear points, the definition of collinear points is like this: if the points are lying on the same line, like collinear points, so points lying on the same line, are called what? Are called collinear points. Yeah, collinear points. That's it. Like here, let us say this is some line, this is some point A, this is some point B, this is some point C. Will you say ABC are collinear point? Yes, definitely, because the point ABC are lying on the same line, same straight line. So this idea is about collinear points. That is it. Yes, so now we have a question here. Okay, let us try to solve this question. I will be a bit quick about it. So let us start from here. Mhm. We have this diagram. So okay, they have given OA is A vector. So first let us understand this part. What is my A vector? So here I can clearly see my OA. Where is OA? Okay, A vector and B vector. That's okay. And OI is, they have given you first. OI is nothing but, okay. So let me write it. I wanted to write OA is nothing but A vector, and again your OB vector is, OB is nothing but B vector. They are representing it with B vector. And then okay, OY, where is OY? Okay, that's it. Hey, when they say OY is double the OB. Okay, that's it. Let me write. OY vector is nothing but double the OB vector, first thing. And second thing, we have OX vector. Vector equals to 5 by 2 times OA vector. Okay, so we will use we will try to understand our diagram better now. Okay, my cursor is not visible here. Okay, but let me try. Yes, okay. Okay, how can I? Okay, so OY is double the, when let us try to understand this. When they say OY is nothing but OY is double the OB. OY is double the OB. OY is double the OB mean B is the midpoint. That's it. So B is the midpoint mean, let us mark this so that uh, yeah, this B is the midpoint of, so this part is equal to this part. I think we understood this. B is the midpoint, first thing. And second thing, what they are giving, OX is 5 by 2 times OA. OX is 5 by 2 times OA. Okay, so we, can I say this way, so double the OX vector, OX is nothing but, 5 by 2 times, double the OX equals to 5 times OA vector. Okay, let us try to write this. So who is larger? So basically, that's it. OX is larger and OA is 5 by 2. Okay, so can I write this way? And write this way mean 5 by 2 is nothing but what is 2.5. So let us, it can give you 2.5 times OA vector. So I'm clearly visible. That's quite understandable. OX is 2.5 times of OA. Okay, that's it. Double and 2.5 times. Let us see in the question how we can use it. So part A, express the position vector of, okay, so first question is part A. In the part A, they have asked express the position vector. So what is position vector of x and y? So see, what is position vector? Position vector of x, basically. Position vector of any point means, a vector from origin to that point, a vector that is connecting, that is starting from origin and ending at that point. So when I say position vector of x mean, I am saying OX vector. Okay, so do we have OX vector? Yeah, that's it. OX vector, we have it. And OX vector here we have it, 5 by 2 times OA. Okay, so OX vector is nothing but 5 by 2 times of A vector. That's it. Okay, similarly, OY also we need to find OY vector. Position vector of point Y. Position vector of point Y means, I think, what? Uh, Origin to that point. When I connect origin to that point, yes. So position vector of OY, yeah. Since OB vector is B and B is the midpoint, so OY is double the OB. We know OY is double the OB. So double the OB means double the 2 times B vector, because OB vector is B vector. Okay, so part A is done. Now let us try for part B. Okay, express AB in terms of AB vector. Okay, AB vector. What is AB? Okay, now we will use vector addition. So you need AB vector. AB vector means ki I have started from A and finally displaced to B. You have to find equivalent displacement. See, I have started from A to B. AB vector is nothing but AO vector plus, okay, let me write it, AO vector plus OB vector. You just have to find any other sequence of journey. My displacement was A to B. When you travel AO and then OB, you will you will have same displacement, and that's it. So AO is what? AO is okay. See, OA is A vector. AO is opposite of opposite. So I will represent it with minus A. Minus A, and OB is nothing but B. So minus A plus B. That's it. Part B we are done. What about part C? Express XY. Okay, XY vector same. XY vector. Okay, so you are asking this one, this vector, XY vector. XY vector same, mean ki you have to start from X and end at Y. So please find a journey. So can I write it? Can I write it? XO plus OY. Can I go a journey of XO plus OY? Yes, I will. This is the same displacement. Displacement XY is same as displacing X to Y and then displacing O to Y. Okay, so now XO. Do we have XO? Okay, we have OX here. Here we have OX, that is 5 by 2. OX and XO are quite opposite. So I will write it minus of XO is nothing but minus of XO plus OY we have, and that's it. OY vector I will write. And now minus of XO. XO is, what is XO? Minus of, no, it is minus of XO. Sorry, minus of, this is OX. Minus of OX. Do we have OX vector? Yes, it is 5 by 2 times, so 5 by 2A. That's it. 5 by 2, 5 by 2 A vector. That's it. Plus, what about OY vector? What about OY vector? Okay, since OB is B vector and B is midpoint, so OY is double the OB. So I can write it 2B vector. That's it. So part C is also done. Now about part D. D. Given that AC is 6 times AB, that's okay. Okay, AC vector. So, okay, OC is 6 times AB. Do we have AB? Do we have AB vector? AB, where? Yeah, we have find it. AB vector is in part B. We have find AB vector is nothing but minus A plus B. Let us write minus A plus of B. Okay. So, yeah, that's it. So, we have this is if I open the bracket, I will have minus 6A plus 6B. So now my part D is also done. Let us move to E, where XC, okay, you need XC vector. Okay, you have to think what is XC. Okay, right now we don't have any XC vector, but we have to draw. Let us draw XC vector. Okay, this is X to C. That's it. I think this is XC vector. Clearly visible. XC vector mean ki XC displacement XC is same as if I displace X to O and then O to C. OC do we have? Yeah, we have just I think found OC or not OC. Okay. XC vector equals to 6 times EB vector, na? But E we are doing AC express OC. Express XC in terms of A and B. So XC definitely I can write that. XO I have it, and OC. Do we have OC? In part D they are given that AC is 6 times this, AC is 6 times this. That's it. Express OC. Okay, I think in part D we have missed part D. In part D we have to find about OC. So let us first complete that. Yeah. What is this? Is nothing but. So given that AC is 6 times EB vector, so now I have AC vector also. What do I have? AC. That's it. Okay. So here OC vector, like if you ask me OC vector, let us do OC vector. What is OC vector? Can I write OC vector as OA vector plus displacement? OC vector mean displacement OC. Displacement OC is same as displacing OA and then AC. Yeah, correct. I think OA we have it. OA we have it. Where is OA, sir? What is OA? OA is A vector. I think that's it. A vector and plus AC we just found. So this is AC is nothing but minus 6A plus 6B. Okay, let us write minus 6A plus 6B. And if I try to open it, my OC vector will be, see, if I open the bracket, this will be minus 6A plus A is minus 5A and then plus 6B. That's it. So we have OC vector. Now we can try for part D, part E. XC vector. Here we have to find XC vector. What is XC vector? Okay, so XC vector. x to c. Okay, it is nothing but xc vector mean displacement xc. I can write xo plus oc. Okay, xc journey xc displacement xc is nothing but xo plus of oc. That's it. And we have both things. What is that? Xo is xo. What is xo? We have find it. Okay, we have ox, by the way. Ox is 5 by 2, 5 by 2a. So xo is minus of 5 by 2 a. That's it. And plus oc we just found. So oc is nothing but minus of how much? 5a plus 6b. That's it. And if I try to open, this is 5 minus 5 by 2a mean minus 2.5, and this is, if I open the bracket, this is minus 5a. Okay, that's it. Minus 5 mean minus 10 by 2, and so this is minus 15 by 2a, and then plus 6b. That's it. So here we found a to e. Now the most important question, and the question for which this question is, I have taken this part F. Use the result of xy and xe to show that xyc are collinear. Okay, we have to show point xyc are collinear. And here we learnt about collinear, I think. Collinear points are points which lie on the same line. That's it. Anyway, we have to prove point x comma. Okay, no. Yes. So point x comma y comma c are collinear. Hey, they have not given us. We have to show it. है ना? We have to prove it or show it. Basically, show this. X, Y, C are the points. Yeah, X, Y, C are the points. Okay, so what we will try now, whenever we have the, okay, so we have to show something like this. Okay, hey, there is some X, there is some Y, and there is somewhere C. I am just trying to get an idea. When we have to show X, Y, C are collinear, mean ki they must be lying on the same line. So the only idea, the concept that we can do now, let us try to find, always what we will do, we will try to find xy vector and yc vector always. So my xy vector and yc vector, I think both we have. Xy vector do we have, and yc, yeah, xy vector in part C, minus 5 by 2a plus 2b, minus 5 by 2a plus minus 5 by 2a plus 2b. That's it. And what about yc? Do we have yc? YC, do we have or no YC? XY, use the result of XY and XC. Okay, okay, that's it. Anyway, C, XC, okay, we have XC. XC is minus 15 by 2a plus 6b. Let us write minus 15 by 2a, minus 15 by 2a, and what, plus 6b. C, this is not XC, this is YC, this is XC, by the way. Okay, that's it. See, whenever we have to check two points are collinear, you can make any two vector out of it. Like xy, we are making one vector as xy, and next is xc. That's totally okay. Make any two vector out of these 3 points. That's it. So xy and yc. For 15 by 2, and yeah, that's very clear. Hey, if I do this way, like I just take na, see the idea, what I will do now, I will try to represent one vector in terms of another vector, and you can do this by just taking 3 as common. Let us try to take common 3. How much? If I take 3, yeah, if I take 3 common from here, I will be left with minus 5 by 2a plus I think 2b. Yeah, and that is, this is your xc. So here I have xc vector. What I am getting, xc vector is nothing but 3 times 5 by 2a plus 2b is nothing but xy vector. Okay, and I think whenever you have any relation like this, one vector is k times another vector, we are quite sure ki these are parallel vector. Okay, these are parallel vectors. Let us try to represent it graphically. So you are saying xc vector is triple the xy vector. Okay, let us try to draw xy vector. Okay, so xy vector and xc vectors are parallel. That's it. You are saying xy. So here with this, the node point, what we have there, can I write like this? Therefore, xy vector is parallel to xc vector. Okay, so let me draw, like, this is my xy vector. This is my xy vector. Okay, this is my xy vector. So where is xc vector? See, I have drawn xy vector and you are saying xy vector is parallel to xc vector. Okay. And one point is common. See, when I try to locate xc vector, I have to start from here. I will have to start from here only. I have represented xy vector. Now I am trying to represent xc vector. So xc vector, the starting point is x. And if you say x, can you? So x is triple this. Can I represent this way? Triple length, triple some xc. No, because if I represent xc vector here, lengthwise, okay, xc vector is triple the xy vector, but here other condition is not satisfying. And what is other condition? Xy is parallel to xc vector. So I have to make it here only. Xc vector is definitely, it should go in this line only, and here I think that is my xc vector. Okay, and now it is very clear. You can see key point x, point y, and point c are lying on the same line. Yes. Therefore, what we proved, since xy is parallel to xc, therefore, the only possibility is point x, comma y, comma c are collinear. So this concept is most important concept in the whole vector, and this concept relies on just two fact, these two facts. Here, these two note point. If two vectors are parallel, you can represent first vector as a vector equals to k times b vector. And second concept, if two vectors are parallel, okay, that is the second note point. If two vectors are parallel, uh, the corresponding component coefficient of a vector, the ratio of coefficient of a vector and the ratio of coefficient of b vector are equal. So k upon k1 equals to p upon p2. That's it. Thank you.